Numerical on superposition principle. In this numerical, three charges Q1, Q2 and Q3 are placed at the vertices of equilateral triangle. We have to find the force acting on capital Q charge at the centroid of the triangle. Now, apply the superposition principle and Coulomb's law. Let the distance between AO, it is equal to x. So this BO, suppose it is also x and it is also x, because AO is equal to BO is equal to CO. Now the force acting on capital Q charge due to Q1, it is represented by F1, because like charges repel to each other. So the direction of force acting on Q charge due to Q1, it is in outward direction. So direction is F1. So force acting on capital Q charge due to Q2, it is represented by F2, and direction away from the charge, this is F2, and force acting on capital Q charge due to Q3, this is F3, and represented by F3, direction away from the charge. Now find the value of F1, F2 and F3. So first F1 is equal force acting on capital Q charge due to Q1, it is equal 1 upon 4 pi epsilon naught Q1 into capital Q by this distance is x, so x square. The charges Q1, Q2 and Q3 are equal to small q. All charges are identical. Then F1 is equal 1 upon 4 pi epsilon naught and small q capital Q by x square, equation number first. Similarly, F2 and F3 are also same. So F2 is equal to 1 upon 4 pi epsilon naught small q capital Q upon x square, and F3 is equal 1 upon 4 pi epsilon naught into small q capital Q by x square. Now the angle between, find the resultant of F1 and F2. The angle between F1 and F2 is 120 degree. This angle is 120. So the resultant acting in this direction, it is equal to F dash. The F dash is the resultant of F1 and F2. By vector rule, by applying parallelogram law, this F dash